Chapter 18, page number 22. So exercise 18F, the first question. Limit x approaching towards infinity, 4x minus 3 upon 2x plus 1. Okay. 4x minus 3 upon 2x plus 1. Now the maximum degree of x is 1. Okay. Now this is x approaching infinity problems. We have to solve this in using a specific way. So the maximum degree in the problem of x is 1. So we'll write divide throughout by x, since the maximum degree of x is 1. Okay. So we are going to divide throughout by x. 4x upon x. See, we cannot just divide the numerator or denominator. You have to divide throughout. Okay. So x is gone. So we are left with 4 minus 3 by x upon 2 plus 7 by x. Limit x approaching towards infinity. I'll go back to the previous slide. 4 minus 3 by x upon 2 plus 7 by x. Okay. Now put the value of x as infinity. Now put the value of x as infinity. Guys, what is 3 upon infinity and 7 upon infinity? Anything upon infinity? Do you know? Zero, correct. Anything upon infinity is 0. So 4 minus 0 upon 2 plus 0. So 4 upon 2, the answer is 2. Just copy. In the meantime, if you have understood this problem, then just share a feedback over the group, over the chat. If you have understood this, then please share a feedback with me. Okay. Question number 2. Should I proceed or should I wait? Okay, so I will proceed with question number 2. Limit x approaching towards infinity, 3x square plus 2x minus 5 upon x square plus 5x plus 1. Now this is x approaching towards infinity. Look at all the x terms. Look at all the x terms. So what is the maximum power of x? What is the maximum power of x? Hello. Hello. Waiting for your reply. The maximum power of x is 2 because it is x square. Guys, are you able to hear me? So the maximum power of x is 2. So the next step is divide throughout by x square. We have to divide each and every term by x square. Okay. So this is equal to limit x approaching towards infinity, 3x square by x square, 2x by x square minus 5 by x square by x square, 5x by x square, 1 upon x square. So x square is getting cancelled. 1x will get cancelled from the middle terms. Okay. So what are we left with? In the numerator, it is 3 plus 2 upon x minus 5 upon x square. Three plus 2 upon x minus 5 upon x square in the numerator, and the denominator is 1 plus 5 upon x plus 1 upon x square. 1 plus 5 upon x plus 1 upon x square. Now what do we need to do? Can you tell me? After this step, can you just suggest what can be done? Please tell me. Next step, waiting for your reply. Substitute what? Value of x as infinity. Correct. So 3 plus 2 upon infinity, 5 upon infinity square, 1 plus 5 upon infinity, that is not defined, 1 upon infinity square. So what about these terms, the green colored terms? What is the answer for this? Correct, it's 0. Perfect. So 3 upon 1. The green colored terms will be 0. Anything upon not defined or not defined square is 0. Okay. Yes, any doubt is there? Pop it. Okay. So go to the third problem. Limit x approaching towards infinity, x cube plus 6x squared plus 1 upon x raised to 4 plus 3. X raised to 4 plus 3. Okay. Look at the individual terms. X cube, x square, x raised to 4. Which is the term with the highest power of x? Or what is the highest power of x? X raised to 4. Or highest power of x is 4. So divide throughout by x square, x raised to 4. So this will be equal to limit x approaching towards 0, x cube upon x raised to 4, 6x square x raised to 4, 1 upon x raised to 4 upon x raised to 4 upon x raised to 4, 3 upon x raised to 4. Now all cancellations. This will be 1. This x cube is gone. This will be x square. So the numerator is 1 upon x plus 6 upon x square plus 1 upon x raised to 4. 1 upon x square plus 6 upon 1 upon x, sorry, plus 6 upon x square plus 1 upon x raised to 4. Denominator 1 plus 3 upon x raised to 4. And this is infinity, sorry. So this will be 1 upon infinity, 6 upon infinity square, 1 upon infinity raised to 4, plus 1 upon 1 plus 3 upon infinity raised to 4. Now, what about this green colored terms? What are these green colored terms? These are 0. So 0 upon 1, the answer is 0. Chalo, tell me, have you understood this or not? Waiting for 2 minutes, some people are copying. Next problem, question number 4. Limit x approaching towards infinity, 3x cubed plus x square minus 1 upon x square minus x plus 7. The term with the greatest power of x is x cubed. Okay, so divide throughout by x cubed. I'm just doing that. Do the cancellations. Do the cancellations very clearly. Next step. Limit x approaches infinity, 3 plus 1 upon x, 3 plus 1 upon x plus 1 upon x cubed. 1 upon x minus 1 upon x square plus 7 upon x cube. Okay. Now put the value of x as not defined. Okay. All the green colored terms will turn out to be 0. So 3 plus 0 plus 0, 0 minus 0 plus 0. So 3 upon 0, which is not defined. So unfortunately, we did some manipulation to avoid the answer as not defined, but then the manipulation didn't work. Okay. So there are certain situations where the manipulations won't work. So there the answer will be not defined. The limit is not existing. Fine. And if you solve this problem using LHL RHL, you'll get the same thing. Limit does not exist. That you need not do. Just for your knowledge, I'm saying. Yes, we have completed 4 problems. Have you understood all these 4 problems, or you haven't understood anything? Tell me. Okay. Next, I'll take you to the next problem. That is question number 5. Okay. Be attentive. Limit x approaching towards infinity. 5x minus 6 upon root of 4x square plus 9. Okay. Now, what is the highest power of x? Can you tell me? There are 2 terms with x and x square. But then what is the highest power of x? Can you identify? The highest power of x will be x itself, because down there is root. So root of x square is x. We will divide throughout by x. See, down there is root. Now root of x square is x. So limit each and every term you divide it with x. 5x upon x, 6 upon x, the square root of, okay, 4x square plus 9 upon x. Each and every term. Now here x is getting cancelled. We are left with 5. Okay, now there is something that you have to learn. Look at the denominator. This x is without root and the numerator has a root. So if I want to send this x within the root, how can I send it? I mean, for this blue colored term, if I want to write a complete root, 4x square plus 9 upon what? X square, right? Because root of x square is this x. So in the next step, I'm going to take that x within the root. And when it goes within the root, it becomes x square. Okay, copy till here. So this equal to limit x approaching infinity 5 minus 6 by x root of 4x plus 9 upon x square. Now we'll split this into two parts in the denominator. 5 minus 6 by x 4x square upon x square plus 9 upon x square. So this is gone. What is the next step? Come on, tell me. What is the next step? I'm waiting for your reward. Hello, hello, hello. Put the value of x as not defined. 5 minus 6 upon not defined root of 4 upon root of 4 plus 9 upon not defined square. Now, what are these green colored terms? These are 0. So, what is the final answer? Come on, tell me, guys. What is the final answer? Correct, 5 by 2. Just complete the problem. Okay. We cannot square root in the beginning because the root has a plus sign. How can we split the root with the plus sign? Okay. Taking you to question number 6. Limit x approaching infinity 3x square minus 1 minus root of 2x square minus 1 upon 4x plus 3. See, there are two ways to solve this particular problem. The first way is to rationalize root minus root in the numerator, so rationalize. But then that is not really required because the maximum power of x is 1. We can divide throughout by x. Okay? Because root of x square will give you x. So the maximum power of x is 1. So divide throughout by x. Limit x approaching 0. Root of 3x square minus 1 upon minus root of 2x square minus 1 upon x. And this is 4x upon x plus 3 upon x. Okay. So this x will go. Guys, what about the numerator? Any suggestion? What about the numerator? Here I will split root of 3x square minus 1 upon x minus root of 2x square minus 1 upon x. So this equal to limit x approaching towards infinity. Okay. 4 plus 3 upon x. Next step. What is the next step, guys? Can you suggest? What is the next step? Take the x term within the root. Okay. The next step is again split within the root, split it. Three x square upon x square minus 1 upon x square. Okay, the root of 3x square upon x square minus 1 upon x square. The other root will be 2x square upon x square minus 1 upon x square. Four plus 3 upon x. X square terms will get cancelled. Now suggest what has to be done. Tell me what has to be done now. Substitute the value of x as infinity. Okay. Green color terms will be 0. So what is the final answer? Is it root 3 minus root 3 upon 4? Root 3 minus root 2 upon 4? Yes or no? Waiting for your feedback. Are you getting the same thing or anything else? Yeah. Question number 7. One second. Done. Okay, now in this problem, I said we can rationalize at the beginning. Okay, we can also take conjugates, but then there was no active need. Question number 7 now. We're solving question number 7. Now, question number 7, unfortunately, there is no denominator. So we cannot divide throughout by something. So the question number 7, the last resort is to take conjugates. There is no denominator like question number 6. Here there is no denominator. Question number 6, we had a denominator. So we didn't rationalize, but in here we have to rationalize. Okay. So rationalize the root minus root term. Rationalize the root plus root term, root minus root term. All of this is multiplied and divided. Root x will remain as it is. We only rationalize root minus root value, value minus root, value plus root, such kind of terms. A single term we don't rationalize. Okay. So this is a minus b, a plus b. Limit x approaching towards infinity. So this is x plus c minus x, a square minus b square. Do you agree with me? Where x will get cancelled. Any doubts in this slide, you can please ask. Any doubts in this slide, you can please ask. The rationalization was required because there is no denominator. Otherwise, we could have done something like question number 6. Okay. Limit x approaching infinity, c root x upon root of x plus c plus root x. Okay. Now see, you have to divide throughout by x square. Divide throughout by root x. Sorry. Because the maximum power of x is half. Each and every term divide with root x. Okay. Now in the orange colored term, we'll combine the roots. Because this is division, multiplication, we can combine, we can split the roots. So we can combine the roots. Okay. So limit x approaching infinity, c upon. Okay, just take a look at the previous. There will be c. Denominator will be combination of the roots x plus c upon x, and this term will be 1. Okay. Now just split inside the root. Split inside the root. Again, this is 1. Now you can put the value of x as infinity. So c upon root of root of 1 plus c by infinity plus 1. Okay, c upon infinity. What is c upon infinity? It's 0. So this will be root 1 plus root 1. Root 1 plus 1. So that will give you c upon 2. That will give you c upon 2. Guys, you understood this problem or no? Okay. Yeah. Let us go to the 8th problem. Question number 8. Now, after solving so many problems, I think you should be in a position to help me over here. Tell me. What is the first step? Rationalize, there is no denominator, so we'll rationalize, correct. Limit x approaching infinity, x square plus x plus 1 minus x square plus 1 into root of x square plus x1 plus 1 plus x square plus 1. I have made an attempt to rationalize. So numerator will be a square, the root goes minus, don't remove the round bracket. Okay. So from the numerator, x square is getting cancelled. So we are left with x plus 2. So limit x approaching infinity, x plus 2, x square plus x plus 1 plus root of x plus 1. Okay. Now the maximum power, I'm not saying minimum, huh? I'm saying maximum power of x is 1 in the numerator also and in the denominator also. Square root of x square is x. Okay, so the max, anyone, divide throughout by which term? X, correct. Divide throughout by x. So x upon x plus 2 upon x, x square plus x plus 1 upon x. This is also upon x. Okay. So this x is getting cancelled. We are left with 1 over here. Guys, what to do with these blue colored terms? When they go inside the root, they will become, when they go inside the root, split अभी नहीं करेगा भाई. You cannot split right now. First, you have to take those terms within the root. It will become x square. Limit x approaching 0 towards infinity. 1 plus 2 upon x. Root of x square plus x upon 1 upon x plus root of upon x square, sorry. And this is also x square. Now split within the root. X square upon x square. 2x upon x square. 1 upon x square. X upon x square plus 1 upon x square. So this will be limit x approaching 0. 1 plus 2 by x. Square root of 1 plus 2 by x. 1 by x square. Root of 1 upon x. 1 upon x square. Now I'll put x as infinity. So what will happen to the green colored terms? One second, have I copied something wrong? Yeah. It's only x, correct. Sorry. So this is 1. Okay. So guys, what about the green colored terms? When you put the value of x as infinity. 0. Correct. Okay. So this will be 1 plus 0 upon root of 1 plus 0 plus 0 plus root of 0 plus 0. 1 plus 0, 1 plus 0 plus 0 plus root of 0 plus 0. 1 upon 1, which is 1. Hey guys, have you understood this? Yes or no? Last problem. Okay. Question number 9. Limit x approaching infinity, n approaching infinity, 1 plus 2 plus 3 plus dot 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 up to n upon n square. Now I'll give you some formula list. 1 plus 2 plus 3 up to n is n into n plus 1 by 2. Now this thing can also be written as summation n. Now 1 square, 2 square, 3 square, sum of first squares of first n natural numbers, n into n plus 1 to n plus 1 by 6. This is written as summation of n square, n 1 cube, 2 cube, 3 cube upon n cube. This is summation of n cube. It can be written as n square into n plus 1 the whole square upon 4. Please copy this. Acha guys, see, listen. 8 sum, I think I did a copying error. This part, x square plus 1 in the next step, in the next slide, I wrote it as x plus 1. I was changing slide, so I got confused. Okay. So make it x square. You can resolve this problem by taking this as x square. Okay, you can do it on your own. Yes, somebody figured out. Neil, correct? This has to be x square. Fine. So you can just resolve this problem. Basics will remain same. Is that okay? Is that okay, guys? In the previous problem. Fine, now you understood, na? Okay. Suppose copy this. Okay. Guys, have you copied this? Oh, 10th problem is also there. Yeah, correct. I'll be solving these two problems. Okay. Yeah. So summation is n is 1 plus 2 plus 3 plus 4 plus dot 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 n. The answer will be n into n plus 1 by 2. Sum of squares of first n natural numbers is summation n square. N into n plus 1. This is n plus 1, okay. Into 2n plus 1 by 6. And summation of n cube. N square, n plus 1 the whole square upon 4. Yeah. So go to the ninth problem. So I'll just write over here limit approaching infinity n into n plus 1 by 2. And there is one more n in the denominator. Okay. Who has not understood this step, please put it over the chat box. I've just substituted the formula n into n plus 1 by 2. Have you understood this or not? Okay. So this will be limit n approaching towards infinity. This n and n will go. So it will be n plus 1 upon 2n. Limit n approaching infinity 1 by 2. Take that n within the round bracket and split it. Okay. So this will be 1 plus 1 upon n. Now put the value of n as infinity. Okay. So what is the value of the red colored term? If you put n as infinity, what is the value of n red colored term? It's 0, correct. So what is the final answer for this? Half into 1, that is half. This is the final answer. Guys, you understood this? Those who are not replying, can you just tell me? Just give me a feedback. Okay. Then the last problem, question number 10. Everybody has copied this. Limit n approaching infinity. Okay. Summation of n cube upon n raised to 4. Now summation n cube formula is given to you. N square upon n square into n square n plus 1 the whole square upon 4. N square n plus 1 the whole square upon 4 into n raised to 4. Where is this n raised to 4 coming from? It's coming from the problem. Otherwise, we have just applied the formula of n cube. Any doubts? Any confusions? So this can be written as n approaching infinity n plus 1 the whole square into 4n square. How 4n square? This n square and this 4 will get cancelled, right? Okay. Now next step, I'll just group this square. I'll put a common square over here. N plus 1 upon n the whole square. Fine. Limit n approaching towards infinity n plus 1 upon n the whole square into 1 upon 4. Why 1 upon 4? Because this 4 is there in the denominator. So that is written as 1 upon 4. Okay. Now within the round bracket, just split n upon n plus 1 upon n the whole square. Put the value of n as 1. What about the blue colored term? If we put the value of n as infinity now, what is this blue colored term? After putting the value of n as infinity, it becomes 0. So 1 plus 0 the whole square is 1. This bracket will be 1. Okay. 1 by 4. 1 plus 0 the whole square. So the answer will be 1 by 4. That is the end of today's session. Guys, just share a feedback about whether you have understood or not.